Here's an example about a clock. Hour hand of my antique Seth Thomas schoolhouse clock is 4.6 inches long, and the minute hand is 6.1. I assume they mean inches long. Find the distance between the ends of the hands when the clock reads 5 o'clock. Okay, what are they talking about? Well, it'd be helpful to do a little clock here if I can do my best to form a circle. All right, that little tool helps. So there's a circle, and we'll put this in the center. Okay, and we'll say it's a 5 o'clock. 5 o'clock. So at 5 o'clock, you straight up 5 o'clock. So we have the 12 straight here, 3 straight here, 6 here, 9 here, and in between we have 1 and 2 and 4 and 5 and 7 and 8 and 10 and 11. Okay, and how are the hands looking at 5 o'clock? Well, the longer hand, the minute hand, is straight up, and they say that the minute hand is 6.1 inches long, and then the shorter hand right here is the hour hand that's pointing at 5 o'clock, and that is the hour hand is 4.6 inches long. That's 4.6, and they say find the distance between the ends of the hand. So this right here, the end of the hand, and this right there, we want that distance. Call this x. That's what we're trying to find, the distance between the ends of those hands, right? The ends of the hands, that distance right there, x. Okay, and we know the two sides, and now do we know this angle here? Well, this angle is 5/12 of 360 degrees, isn't it? You tracking with me? Because can you see this as this hand, if you go straight up and then the other hand like moves around, from straight up, when you're pointing at 5, you're 5/12 of all the way around, right? If you're straight up, then all the way around is 12 hours. So if we're at 5 o'clock, from straight up, that's 5/12 of all the way around, isn't it? It's 5/12 of 360 degrees. So that is 5/12 times of, in math, always means times. 5/12 times 360. If you multiply that in your calculator, you'll get 150 degrees, I believe, right? So 5/12 times 360. Yeah, 150 degrees. That's 150 degrees. So that angle right there must be 150 degrees. So, okay, so how are we going to solve for x now? We got the angle, we got the two sides. Do you realize we're going to have to use law of sines? Why? Well, we're talking about this triangle right here, right? That triangle. It is not a right triangle, so we cannot use SOHCAHTOA, right? Also, it's we do not have angle and opposite side pair, so we cannot use law of sines. Going to have to use law of cosines, right? If we had, like what I'm saying is, if we had this angle and we knew the opposite side, we don't. It's x. It's what we're trying to find. Or if we had this angle and the opposite side, we have the side, but we don't have the opposite angle. We don't know it. Or we have this side, but we don't know the opposite angle. We have no angle and opposite side pair, so we can't use law of sines. So we must use law of cosines. So how do we use law of cosines? Well, you remember the law of cosines right here from the exam 2 note, the 10.1, 2, and 8 notes. So there's three versions. Remember, the A's across from A, B's across from B, C's across from C when you use the law of cosines. Formulas. A is across from angle A, side B is across from angle B, and C is across from C, with the other two letters in between, right? A is across from A with B and C in between, or B is across from B with A and C in between, etc. So they're basically saying use any side you want, opposite angle, other two sides between. So let's go back to it. So we're trying to find x there. So we're going to say x squared equals the other two sides, 6.1 squared plus 4.6 squared, it doesn't matter what order, minus 2 times 6.1 times 4.6 times the cosine of the angle opposite x, right? What's opposite x? Is that 150 degree angle. This is 150 degrees right there. That's what we found right there, right? See how we've got side and opposite angle? That's what the law of cosines says you've got to do. All right, so really I'm just going to hit the buttons on my calculator for all that stuff. Make sure you're in degree mode, because that's a degree, not radians, right? So make sure you're in degree mode. I'm getting x squared is 106.9713457, but then you've got to root it, don't you? Root it. So I'm going to hit second square root of the answer, because that was x squared. So x equals 10.34, I don't know how many hundredths of an inch. That's all they want. Hundredths, two places. 10.34 inches. So those hands, the distance from here to here must be 10.34 inches at 5 o'clock. Interesting, we can find that. There we